Welcome to lab session 3 for COSC210 database management systems. Today we're going to finish up our look at SQL. It won't be the last time you've seen SQL in this course. You'll be practicing it and using it as part of the other practical sessions, but this is our last specific tutorial covering off on the content from chapters 4 and 5 from the prescribed text. So as usual, we'll be going through and uploading our company database to a new database, so MLHA prac03. I'm still using my prac2 database here just to be quick for today. But again, we need to have all of our company database tables and the data within them uploaded so that we can so that we can carry out some queries on our database. Now, there's a few topics we're finishing up with today. We've got string comparison operation, arithmetic operators in queries, grouping and aggregate functions, and the final topic there looks at creating views, which are virtual tables. So we'll kick right in. So go through, create your database, log in and run your prac1 SQL script into that database. If you have any problems with that, let me know. Otherwise, we'll move straight in. The first section looks at the string comparison operations. So far through the practical exercise, we've simply compared string type attributes to determine equality. So we've said if string 1 equals string 2, and that's been the scope of our comparison operation. Now, SQL and Postgres, or Postgres implements a range of facilities for complex pattern matching of string type attributes. So pattern matching is achieved through the use of the like operator. So the pattern matching facilities can be used for identifying partial matches to patterns. We've got a couple of reserved characters. The percent character is an arbitrary section of 0 or more characters, and the underscore is used to specify a single character. So the reserved characters are simply inserted into the comparison literal on the right-hand side of the like operator. Now that's a bit of a mouthful there, but if we jump down into some examples here, we can see that if we want to return all employees who have an address in Houston, Texas, we don't really care what sits either side of the phrase Houston, Texas. So we'll actually put a set of percentage symbols either side of Houston and Texas, or the abbreviation for Texas there. So that means that we can have any number of characters before, any number of characters after this string, and it will be matched in the like operation. So if we throw that example into our database here, we can return the names of employees who are from Houston, who contain Houston, Texas in their address field. So I'll actually go back and make a quick modification to that example by putting address in there, and you can see that we've returned 5 employees. All of them have that string in the address. Note that we've got the space in there. If you remove the space, it wouldn't match up either. Likewise, we can use the underscore operator to specify the presence of characters in our pattern. Here we have an example where we're finding employees that were born in the 1950s. Now, we have to perform some gymnastics on the B-date field. So recall that the B-date field has been saved as a date type field, or I've saved it as a date type field in my example. So if we grab the description of our table, we can see that the B-date field is a date type up here. If we look at the data in that date type field, so if we select B-date from our employee table, you can see that we've got our full year stored in there. Now, it's stored as a date type, not as a string type, so we have to perform some gymnastics to pull out a string representation of the year. And we do that by using the date part function. Now, the date part function is one of the date functions provided by the Postgres database management system, and it takes as input a component specified as a string. So in this situation, we're specifying that we want to grab the year component of the date, and it takes the date type field we want to operate on. We then have this special double colon operator. Now, this is the typecast operator, and what we're saying here is we want to convert the result of this function to a varchar. So essentially we're converting the result of the date part function, which is usually an integer or double floating point, double precision floating point number. We're converting that to a string. We're then using it in our string comparison operation with the like operator. And in our comparison string, we've got 2 underscores before a 5, followed by a single character. So we'll start to execute this query. We'll start by breaking it down, and we'll actually grab the employee, and we'll grab the date part to show you what's being returned by that function. So if we go back and drop that in, oops, doesn't want to do that for us. I'll just execute that one to get it out of the way. If we go and select our first name and last name, and we're going to grab date underscore part year, and we're grabbing it from the bdate field. We won't typecast it just yet so that you can see, oops, should be bdate, sorry, bdate. You can see that we grab the year component. And when we cast it to a string, cast it to a varchar, it shouldn't make any difference to how it appears, which it doesn't. So now we can perform so you can see that we've grabbed the year component, and we want to only grab the years that have a 5 in the 3rd character across. So we only want to grab these 1950s dates. And when we execute that one, we'll see very quickly that we're only returning a few of our records. I'll go back through and I'll just drop the year into that example so that you can see. I should just put the B date, sorry, into that one so that we can see what we're grabbing. And we can see there that all of the records returned have a 1950s year. If you wish to use the % and underscore characters as part of a string literal for matching, you can escape them using the / operator. So the / operator will tell this pattern to interpret that character, the underscore or the % character, as an underscore or a % character, and not the operator as we've been using it up here. There's a few more interesting examples in the Postgres documentation, and I'll allow you to go through and have a look at those in passing. We can mess around with some other examples down here as well. So if we wanted to select, we didn't care if we want to use the % signature symbol to match up to an arbitrary string. You can see that that one evaluates to true because the first character in our comparison string is an A, and we don't care about any of the characters afterward. And I'll let you go and run those in your own time to clarify those in your own mind. The similar to operation supports the use of pattern matching characters borrowed from the POSIX regular expression, so regexes. And we have the full list of characters for building up those patterns. You won't be using those very much in this course, but we can build up complex patterns. So for example, we can use repetition 0 or more times, repetition 1 or more times, repetition of the previous item 0 or 1 time, and so forth to build up our expressions. But you won't have to deal with these much in Postgres, so don't concentrate too hard on those. We've got a few simple examples below here. In our queries, as part of the select clause in our query, we can apply standard arithmetic operations to get Postgres to carry out simple calculations for us. So if we wanted to, for example, apply a 10% salary rise, we could simply multiply our salary value by 1.1. If we wanted to add up values, we can do that as well. You can perform any of the basic arithmetic operations as part of the select clause to return data that you want to calculate, and the server will calculate that. So the advantage there is that you're doing the calculations in the database server on the item that's returned. So there's a full list of math functions available to you in Postgres. So that's a relatively simple example there where we're giving everybody a salary rise where they work on the product X project, and we're doing that by multiplying the salary returned by 1.1. The final section here today looks at grouping. Final section dealing with queries looks at the aggregate functions. Now, aggregate functions are used to summarize information from multiple tuples into a single tuple summary. You might know some of these functions from Excel spreadsheets, for example. So the functions supplied, the simple ones, include a count, sum, max, and min and average functions. So given a selection of tuples, we want to summarize this information into a single tuple. So if we wanted to do a count operation, we would count all of the subtuples. If we wanted to add them up, we could use the sum operation. Obviously, we need to use these operations on valid attributes. So you can't sum a varchar type attribute. You can't get a min and a max from a varchar, and you can't calculate an average over a varchar, but you can count them. So you have to make sure you get your type right, and if you don't, it'll turn out an error. So here we have an example. Find the sum of all salaries, the max of all salaries, and the minimum of all salaries in the employee table. If we run this query, we'll see that we get a single tuple returned, and it's summarized all of those values. So it's added up. In the first situation, it's added up all of the salary values returned by all 40 records in the employee table. In the subsequent two items here, we've grabbed the maximum salary and the minimum salary. So you can see that we've performed this aggregate operation to summarize multiple tuples down into one tuple. We can match this up with our use of the where clause. So if we wanted to find the sum of all salaries and the maximum of all salaries and the min of all salaries from the research department, we can do so by placing this filter in the where clause that's only on the research department. So if we drop that one in, we'll get a much lower result as returned from the previous example. The count operation can be performed on any attributes. In this particular situation, we've used the wildcard operator because we don't care what attribute, to count rows. So all it does is count the number of rows that we've returned, and again we can put filters on that. So if we wanted to count all employees, we can just do a count of all employees. We've given that column an alias by using the as operation. So you can see we've got an example here where we've got a column that's got a heading count of all employees, and we've got 40 employees in the database that's successfully counted. We could chuck an additional condition on here. So if we grab our previous query, because it's already got the department join in it, we can put a count on here as well. So if we want to count the number of employees that are in the research department, we could just drop in a count wildcard into this one, and you can see that there are 4 employees that it's counted in the research department. We can combine that with distinct as well, so we can use the distinct clause to count distinct tuples as well. So if there's duplicate tuples returned by a subquery, we can wipe out the duplicates using the distinct query. Now, sometimes we want to summarize our returned attributes and organize them into groups. So in many situations, we'll need to apply aggregate functions like count, sum, min, and max to subgroups of tuples. So we do that by using the group by operation. So before we cover off on these other points, we'll jump straight in to an example. So if we wanted to retrieve the number of employees and the average salary for each department, we could use the group by operation to group tuples in the employee table by the department number field. So if we execute this query, we'll get a one row for every department number in our employee table. So we can see that it's summarized all of these items by the department number. So we've got one row for each department number across the employee table. So there are 6 departments, and we've grabbed the average salary for each one and the count of employees in each table. So if we added up that count column, it's going to add up to 40 employees, because we have 40 employees across the whole table. Again, we can restrict rows in our groups. We can use using the having clause. So here we have an example. The having clause puts a condition on the summary information. Only groups satisfying the condition will be returned. So if we wanted to, for each project that has 2 or more employees, list the project number and the name of the employees. So here we put a having clause in, and we're only counting groups that we only want to include groups that have a count greater than 2. So we put this having count star greater than 2. When we execute this query, we'll return only project names that have more than 2 employees, and we've returned that count as well here in our example. So run through and have a play around here. You can remove the group by clause to see what the results are, and play around with those in your own time. There'll be a question in your in your first practical assignment where you'll be working with aggregate functions, aggregate queries, and also grouping. Aggregate functions and also grouping. The final topic in today's video covers off on creating views. Now, database views are virtual tables derived from either one or more base tables in your database. Views are used to provide an additional layer of abstraction between the implementation of the database and other user applications that plug into it. So if you make changes to the underlying data structure, so you might change table and column names, you can simply change how your view returns the data from those underlying tables without the need to change how your outside application interacts with your database, because it's interacting with the view. So we simply update the view to return the format expected by the applications. We create our views using the create view function. We're using the create view clause, and we have the as clause to specify the query that the view will represent. So we have some examples here to get you kicked off. If we want to create a view this view directly inherits the names of the selected attributes from the base table. So here we're creating a view called works on 1, and we're creating that view to return the results of this query. So we're selecting the first name, last name, P name, and hours from employee, and we're joining the employee to the project table via the works on table. So we've got 2 conditions here to join our project table to employee via the works on table. So when we execute that query, it will create our view. So we've now created a view called works on 1. We can now look at the contents of the view. So recall, this is a DDL function. It doesn't actually return any data from our tables. It just creates the view that will return the data from our tables. So if we go and view the contents of our view can now be accessed as if it was a table, and you can see that we're grabbing all of the records from our table. So we've got 48 rows of data of all of the employees that work on the different projects. We have a second example. This view renames the attributes and makes use of the group by clause to return the number of employees and the total salary for each department. So we're creating a view called department info. Department info will have these named attributes, so department name, number of employees, and total salary. Now, the department name maps directly to the department name selected from the query, and the total number of employees and total salary are created from these aggregate functions that we're applying over our query. So the view will return the contents of this query. So it'll select the name, count, and sum of salary from the employee and department tables. We're joining the employee and the department tables. We then group them. So if we go and create this view, you'll see an example of the item returns. Sorry about that, guys. I need to stuff that up. Drop that in. We've created our view. We can now select the contents of our view by using a simple select query. And you can see that we're counting the number of employees in each department, and we're grabbing a summary of the salary for each department. So it's very useful for creating virtual tables and creating different views of the data that different users can get access to. We can drop our view by using the drop view command. So by issuing a drop view command, you can see that that's been successfully executed, and when we go to try to look at it again, we get an error created. So now we have some exercises for you. So in the first set of exercises, you're creating some queries that make use of your aggregate functions. You're following up with creating some views again that make use of a range of the query elements that we've looked at so far in this subject. So these exercises really do tie together all of what we've covered in the last 3 practical sessions. So run through those and have a look at the solutions to see if you're right. If you have any questions, please send them through. Thanks for listening, guys.